Moving over into Inventor to take a look at just how parametric design works, I'm going to go ahead and start a new part and start a new sketch so that we can see just how parametric design works. I'm going to go ahead and just start from my origin point with a sketch, and I'm just going to define by lines a offset rectangle with an angle on it. And you can see inference lines, things like that, and we'll go into more design aspects and how to use some of these tools in more detail later on. What I would like to just show you is how parametric works. Now let's say I defined a circle, and I'm just going to have a circle in a void in this hole, and I'm going to go ahead and create a dimension that's going to constrain this circle in the x direction to the edges of this part. Now I'm going to go ahead and just define this as a 1/2 inch, and you can see that that scales everything up. Now that's one thing about parametric design that's right off the bat you're going to see is that 1/2 inch scaled everything accordingly to my sketch very simply and quickly. So now when I go ahead and define these edges, they're going to be closer to what my initial design intent would be. So in this case, that's going to be 1 inch. And we're going to go ahead and make this 3 inches even. We're going to go ahead and define this angle as 45 degrees opposite. So what I'll go ahead and do is make that, what that would actually be, 135. Now that that 135 is defined, that's our 45 degrees there again off of the y-axis. So I'm going to just do the last thing we need to do to constrain this sketch, and you'll like I said, we'll go into more detail later on how to do all of this. This is just showing you parametric and kind of some of this more simplistic ideas behind parametric design. We're going to make this 1/2 inch as well. That kind of centers everything, and we're going to give it a diameter of say a 1/2 inch. Now, the way this works, if this parametric design, if any of this changes, like let's say I change this 3 inches to 4 inches, you can see that that automatically forced the constraint to this edge to still maintain its 1/2 inch. That is the biggest difference between legacy and parametric design, especially in the sketch environment. Now I'm going to go ahead and finish this sketch, and we're just going to go ahead and just simply extrude this portion of it, and I'll leave it at 1 inch so that I have a solid. Now it also means that in parametric design that if I go ahead and change one of these features, that I can quickly edit, say, the sketch environment here, change this to 1 inch, and the rest of the design will update, including the solid. So you no longer have a disassociation between the solid or any of the geometry that's going to control our CAM process. And I'll jump over to CAM real fast. We're just going to quickly run through this, create a setup. I'm going to go ahead and leave everything where it's at just to get through this so that you can see when I define something, whether it's a drill or something else. I'm going to go ahead and just grab this spot drill, put a toolpath to it, and you can see that this is a set position from our origin point. Now if I move this hole by going back into our 3D model, and on this instance I'm going to use direct edit real quick just to show you. My CAM automatically knows something's up, but I don't have to go in and redefine anything. All I have to do is regenerate that toolpath, and automatically that parametrically corrected itself to the design intent.